Very good day. So today I will show you how we're able to derive backpropagation algorithm based on the given neural network model. So for our model here, it comprises of the three main elements. The first one is the input layer, second one is the hidden layer, and then the third one is the output layer. So for these configuration models, we have the series of input from x1 to xn, and then the corresponding output from y1 to yn. So basically, first thing first is that we give the label for every item to ensure that we're able to utilize the parameters later on for the derivation process. So for the input layer, we give the label of I, for the hidden layer as J, and then for the output layer as K. So for every in between of the input layer and hidden layer, we have the wake here. So all the wake here will be labeled as Wij, and then the same thing with the configuration from hidden layer to output layer, which is the wake in between to these corresponding two layers will be Wjk. So the next thing is that in terms of our bias, so the bias that is connected to the hidden layer will be labeled as Bj for every path in the layer, and then finally for the output layer, bias connected to the output layer will be labeled as Bk, since this bias connected to the output layer. So this is all the label regarding our models. So the next part is that we try to zoom out in the small part here, in which for our node, for every node, we will define the node as two items, which is the left part will be the summation part, and then the right part will be the activation part. So for the input part of the summation, we will give the label as net for the summation, and then for the output, in this case, S is actually the sigmoid function, sigmoid activation function, and then this is the symbol for the linear activation function. So sigmoid activation function for this case will be defined as S will be 1/1 plus E minus C net. C is the parameters that will control how flat is the sigmoid function. So in order to make sure that we can simplify the equation, we just put C equal to 1, so that our equation will become 1 plus 1E minus net. So net will be corresponding to every layer. If this is in the layer of hidden, it will be net J, and in the output layer will be net K, respectively. So we have all the parameters, labels for the neural network configuration. So the next part is that we can start derive the backpropagation process. So during the training process, we have two phases. The first phase is that from input to the output will be defined as the forward pass. Forward pass means that we supply the input with some samples, and then it will move along the layers up until the output, so we get the predicted output for that particular condition. So the second phase is the backpropagation. For the backpropagation will utilize the output that has been calculated, and then feedback that things to every layer in a reverse order of the forward pass. So one thing that we should remember is that during the training we will given our sample label as x, x1, x2 until xn, and for these samples it will be labeled using t. T1 is the label for x1, so t will be defined as the target during the derivation process. So now we can move on to the next part, which is we will define in terms of forward propagation.